Shall I start?
Just a minute, sir.
Okay, sure.
Good afternoon. A very welcome to all elected dignitaries, faculty members, researchers, and their party never exhausts the mind. It only ignites new possibilities. We are excited to have such an enthusiastic gathering today, united by a common interest in artificial intelligence in pharmaceutical research and education. I am Ms. Shraddha Rao, Assistant Professor of Pharmacology, Rajendra Gode Institute of Amravati. Give me immense pleasure to anchor development program. Before we move ahead, let us briefly reflect on yesterday's enriching session there and reference management. The session provided valuable insights into smart literature screening using AI tools, structuring research flows through AI assisted flowcharts, and efficient reference management for high quality publications. It truly helped us understand how AI can simplify and strengthen the research process. Building on that foundation, today we take a step further with an equally exciting and practical topic: AI and machine learning for non programmers. As the programmer to use powerful technology, only curious enough to learn. Artificial intelligence and machine learning are no longer limited to computing care, education, and machine learning, making them accessible, understandable, and applicable. And for that, our today's guest speaker, respected Dr. Debanjan Sen sir. Sir, we are truly honored to have you with us today. On behalf of Dr. Rajendra Gode Institute of Pharmacy and Dr. Rajendra Gode College of Pharmacy, I wish to introduce Dr. Debanjan Sen sir, academician and computational chemist with expertise spanning in AI-driven drug design, computer-aided drug design, tool development, and organic synthesis of novel small molecules. He earned PhD government book chapters and holds two Indian patents on small molecule based protein inhibition targeting triple negative breast cancer. His research focuses on innovative synthetic routes and molecular scaffolds validated through in silico, structure based, and rational drug design approaches. Notably, he has also developed several computational drug discovery software tools aimed at making accessible. We eagerly I Dr.
Am I audible?
Yes, sir, you are audible.
Okay. Thank you, Doctor. Thank you for your kind introduction, and I'm really thanks to Dr. Rajendra Gode Institute and College of Pharmacy and Technology, Amravati. I'm thankful to Dr. Javarkar sir and Dr. Osoli ma'am for providing this platform and for this privilege. Thank you. Uh, Let me start. I think I can share my screen. Okay. Is it visible to everyone?
Yes, sir, it's visible.
Okay. Okay. It's a long session. I think 2 to 5. So in between, if the participant thinks they need a break, they can take a break. And during my lecture, if you have any query, any doubt, you can raise your question or queries. I will try my best to solve it. And it will be a bit technical. So you may face some, you often encountered by some issue, so no worries. And I'm comfortable with Hindi, English, and Bengali, so okay, we can manage. And another thing, you should not hesitate, just learn it. So today we are going to discuss upon the AI and machine learning for non-programmers, and we'll understand it. What is machine learning? What is AI? Every day we are using it, how it works, and what is the implementation? How we can implement it actually in our real life. Okay, so there is a myth that to do AI ML you should know coding, but no, not like that. But every day we are using AI or ML tools every day. In Google search, you can say in Netflix, in drug discovery, in the diagnosis. When you do your Facebook, it is use very good algorithm. In Insta image processing, they're using AI. So and nowadays in every path, when you order something from Amazon application app, AI or ML something is going there, working there. And in fact, your Facebook, when you are not using your phone, it can listen to you. They stated it. If you open the Google Play Store and in the description section, this clearly mentioned they can hear you, they can see you. You are not using Facebook, your phone is off, you are not handling your phone, but it is kept aside. So if you discuss something, it can hear and accordingly you can see the ad, it can access your phone. So all these things is there any issue in that?
Hello?
Okay, you can connect my lecture with more with drug discovery related issues. Okay, fine.
Yes, sir.
Okay. So before dig into AI and ML and all, first of all, we have to understand what is traditional programming and what is AI and ML. From our childhood, we are using computers, mostly Windows. We are using Excel. We are using Word. We are using some software tools for drug design like Civil, MOI, old tools, Autodoc, Vina. These are traditional programming tools, how they work. Suppose you have two variables, that is X1 and X2. So in traditional program, we define the relationship between X1 and X2 in any form, that is, they have addition function. And every time you will get a Y value that is 5. That is 2 plus 3, 5, 4 plus 1, 5. So we actually in traditional program, we manually define, explicitly we do programming. Explicit means extensively we programmed and we write lots of codes and we define the logic, we define the relationship between two variables, that is X and Y. They are in addition relationships, so output is always a product of addition. So this is our addition function. We define it in traditional program and we write it, we develop a tool or software. But in AI and or ML, it is all about algorithm. We provide some input as well as we provide output. On the basis of input and output, it will find the relationship between inputs. And what is the benefit? So for future perspective, for a given input, what will be the output? That will identify. So what is the basic difference? In traditional programming, what is the relationship between two variables? For instance, the variable x1 and x2. In traditional programming, we define it. For this case, it is addition function. For AI and ML, we provide input as well as the output. From the input, this is the algorithm. It will identify what will be the relationship, and it will give you the output. Clear to all?
Yes, sir.
Okay. So, algorithm, we use AI in AI and ML. We use algorithm to find the relationship to get a result. So, where the story come? Why we need to learn AI ML? Because this is basically for engineering things and for our pharmacy point of view, what is the necessity? So there is a story. Actually, in our lab, we use some tools like DrugX for and we use IRMD. You can send
Hello? Am I audible,
some
sir?
backup molecules. Then
Hello?
we use RT. Yeah.
Your voice is breaking, sir.
Yes.
Your voice is breaking.
Yes.
Maybe.
My connectivity is okay. Hello, check. Now it is okay.
Yes, sir. It's okay now.
Okay. Okay. Uh, okay. And again, I'm repeating. Initially, in our lab, we extensively use DrugX. It is an AI tool, and it is very good for de novo design of a molecule. And after de novo design, we use PyRMD for virtual screening. It is very fast. You can screen lakhs of molecules in minutes, millions of molecules in hours. And we use RTDoc. It is very fast RTDoc. Then we use BAT to program BAT one initially. Recently, they launched BAT two, and it is very good without doing molecular dynamics. You can predict the free energy, so you can get a glimpse what type of molecule you have for synthesis and all. But we encountered by some problem. So the problem is for 60 to 70% case, a data set, it's work nice. But in 30% case or sometimes 50% case, the output is very worse. Computer is saying this molecule is good. When you synthesize it and went for the activity, we find no, we are not. We are ended up with some low active molecule. So what is the issue? Are they wrong? So we are in thinking. So in the early morning, a news arise that people discovered a molecule that is rentoxicity. Wow, that means these things work, really work. And it is an imidazole-based molecule, feasible molecule, and I take the reference from here. And that makes us, that sensitizes us that, yeah, these things work, but why not? So, we Indians, so we do not believe in knowledge. We have to check it in thorough that is it the only molecule by chance, or there are some lots of success story. So from the literature search and web search, we find, wow. So within 3 months, Eli Lilly company discovered a molecule and got FDI approval. That is baricitinib for COVID-19, because initially it is a rheumatoid arthritis medicine. And in the October 27, 22 to 2022, they get approval. So it also considers as, yeah, AI-assisted repurposing maybe help us. So any other tool. Then when we again search the literature, we find there is a molecule called helicin. Wow, good. It is in preclinical trial, new antibiotic, and they discovered it by the help of AI-assisted de novo design, and it matched with us. That yeah, we are doing also a de novo design. Then what happened? We are not getting anything. These are the default tools, the tools they publish in very good paper. But in our case, it's not working. It's not generating very good output, or it generates some molecule. By looking the structure, you think, oh my God, synthesis of this type of molecule takes 2 or 3 PhD. So these are not feasible. So, or you have to employ some synthetic method. This method is really tough, and really these methods are very difficult to perform in some institute research lab like us. So what happened? So what is the thing? Then we also search the literature and we find that AI is also used in drug optimization. And lots of the molecules from 24 months to 30 months, they are optimizing one molecule and they are in preclinical or clinical phase 1 study. That means it has something. Now I started to read literature, and we find some new terms, that is VAE, that is generative adversarial networks, reinforcement learned neural network, the transformers, diffusion model. What are they? What are the things behind it? So that certainly encourages that we need to learn what actually going on, why it's not working all the time, why it is 50 to 60% or 70% correct, not 100% or very good, producing very good result for our case. So if we see the literature, because I'm an old school man, and in my PhD we used to do COMFA, COMSIA in QSR era, and recently we find there is an emergence of machine learning, deep learning, and all. And we know the success story, we know everything about QSR that actually you do. But when we are shifting, we are unable to cope up with it, and we are not engineering guys, so what we do? So we start to learn it from the scratch first. And that will generally help us or motivate us to dig into AI. And I think it is a pretty good cause to dig into AI. And most of that a large number of college has doesn't have the access of very scientific literatures like Elsevier or something. And nowadays, Sci-Hub is not there. And most of us will face issues like solvent, chemicals, IR, NMR machine for the synthesis, cell culture facilities. But we have to do research for the existence. So all these things will help us. Let me learn AI. And initially, I find that to do AI, ML, you need a very big computer. very hard, costlier computer like GPU and all. So my lab is working. I will show you that using your simple computer, using simple algorithm, how you can use it strategically, tactically, that using a simple computer, how can we can perform this work. And I think this is a very good motivation for us to dig into AI. So think we know nothing about AI. Nothing. We have just heard the term AI. What is it? Artificial intelligence. What artificial means? Man-made. And intelligence means thinking power. Okay. Then technical definition of AI actually given by John McCarthy. According to him, it is nothing but the making of intelligent machine. Okay, which can learn, which can understand information, we can solve a problem, we can cope up with new situation. So it is this proposal. So that means AI is creating an intelligent machine. Don't confuse. AI is not a software. No, it is no AI software. No, nothing. It is an intelligent machine. We are making some machine. It is an ecosystem. It is a combination of number of things which can behave and think like human and also able to make decisions. Then what is intelligence? For human perspective, it is a mental process. Like we can recognize some pattern, we can deduce something, we can learn, we can memorize, we can gather knowledge, we can translate some language, and many more things we can perform. But from computational point of view, intelligence means ability to achieve some goal. You have some target, that machine can go and perform that work. Okay. So yeah, nowadays a term came generative AI. We are using GPT, Chat GPT, that is generative pre-trained transformer. Very big word, transformer. We'll discuss it later. Generative pre-trained transformer. That is based on generative AI. So as I discussed earlier, that is artificial intelligence means making intelligent machine. And what is machine learning? Without explicit programming, or basically machine learning is a subset of artificial intelligence. So here the machine learn from data without explicit programming. It use algorithm and it learns from the data. Then come to deep learning. What is deep learning? This is nothing but use of artificial neural networks to get patterns or to learn from complex data. In depth, you can learn. And in deep learning, we use generally neural networks. And next come generative AI. It is nothing but it can generate some text, image, music, song, even molecules, if it get proper input. So nowadays we are using lots of AIs. So they use this generative AI in background. They use either LSTM or SVM support vector. No, not support vector. That is LSTM or reinforcement learning process. It will generate something. So in a layman language, I can say all we are faculty. So we have two students. So before exam, 1 month before exam, I provided or we provide, suppose we provide 10 questions to them as a suggestion for exam. So one student only studied that 10 question 1 week prior to the exam. That is the common practice. I also did that in my student life. So this, just for 1 week before we did the 10 question, we passed the exam. That's it. And another student studied big book, Lachman, Liverman, or your very big books. And in depth, the second student studied the 10 question and associated knowledges. Then in the exam, they may score good mark. But if you ask some question to the second question, you will get more information compared to first student who learned only 10 student before 7 days of the exam. That is machine learning, and second student is the deep learning. Okay, so we will discuss it in in-depth mode. So as I discussed, for recap, take-home knowledge, your artificial intelligence is like a machine which can behave like human. Okay. And your machine learning, it is a subset of artificial intelligence which can learn from the data using some algorithm. And your deep learning is mimic our brain. It uses neural networks. We'll discuss in depth what is neural network, how we can build it. And using neural network, it can understand the data, it can find very critical patterns from the data, and it train the system and give us the output. So briefly, this is AI, ML, and deep learning. So what we can do, you can get your personal assistants like Cortana, Google Assistant, Siri. These are the personal visual assistants with the help of AI. You can get, you can say play music, so and so. It will perform the tasks for you. Then you can build your own AI. Nowadays, GPT models are trained some 64 or 70 GB for a train file. If you download, you do some small programming, you can customize your assistant as per your work. It will do all the work as per your need for your official or personal time, and can solve real-time problem. And most important thing, where human can survive for a task which is riskier for human, AI can do it. Like army is using some new robotic mules and all for performing risky tasks. So number of things you can do with AI. So if you look about the history of AI, it starts from 1950. The term AI coined in 1956 in Dartmouth conference occurred in USA. Everything is in USA. And in 1980s, some expert system built. In 1997, there's a great chess player from Kasparov. So Deep Blue won chess AI. It is a rule-based AI. We'll discuss what is rule-based AI. That beat a human in chess. Then in 2012, deep learning Alexa first came into the play. Then from 20 onwards, we'll get GPTs, ChatGPT, Gemini, Copilot, lot of the things. And now the era of AI agent and agentic AI. Two term I use, AI agent and agentic AI. What are they? We'll discuss that. So we are pharmacists. At the very end, we all are pharmacists. So how AI can help us? So certainly in drug discovery and development, in the manufacturing, supply chain management, clinical trial optimization, then in drug safety monitoring, then to get personalized medicine, and in pharmacy automation, where we can use AI. Okay, and my lecture is chiefly focused on the drug discovery and development. So what are the things we can do with AI in drug discovery and development? You can synthesize molecules, you can design a peptide, you can repurpose some drug, you can perform ADMET analysis, you can search literature, you can get current information, then you can study protein folding. That is Rowan Lab, Bolts 2, very good, powerful tool. So AlphaFold. So you can perform protein folding. These things you can perform with artificial intelligence from my or our perspective view. From our perspective. So now, it is a traditional thing that every time while we study pharmacy, we read classification, pharmacological classification, chemical classification, like this. We should know the classification of AI. Basically, it is two types. We can classify the AI in terms of capability and functionality. Capability means what AI can do and how AI can do, how it does. So on that basis, we can perform narrow AI, reactive machine, limit memory, or general AI. Basically, few AIs are science fiction and yet not exist. They are just conceptual. So along with it, I will provide a real-world classification There is practical classification of AI, that how we classify the AI as per our need, that I will give you later. So this is the bookish, what that is written in some book. So there is a bookish classification of AI. And if you read the whole book, I'll make a table for you. You can take the screenshot. You can go through it. It is just what is narrow AI, generative AI, making a long slide and discussing everything. It is nothing to understand what they do, what is their features, everything. I make a table for easy understanding. So basically, the AI we are using nowadays, it is narrow AI or weak AI. And these AI are limited to only one task. So they can learn from the pattern of the data. They can predict something. They can perform classification. They can provide you some recommendation, but they are lacking of reason. Another AI is general AI. We are expecting that general level AI is a human level, possesses human level intelligence. But these are conceptual, does not exist yet. And another one is super AI. It is, you can see this super AI in some movies where the robot is more intelligent like human, and that is in Terminator. And Terminator 2 is a good example, Terminator movie. So then AI robots are very intelligent and compared to human, they came from the future. So these are speculative and these are theoretical yet not exist, present in science fiction only. Okay. So in the second type, on the basis of capability, functionality, capability we discussed, and on the basis of functionality, that is reactive machine and limited memory AI. 1 minute, please. So reactive machine means it can perform on when you give some input. On the basis of input only, it will perform some work. Without input, autonomous, it can't do anything. Another one is limited memory AI. So it can remember some extent of past experience, and on that basis, it can take some decision. This is your 1 minute. What happened to it? Okay. So it can, from past experience, it can learn something, or from the past data, it can learn something and perform some work. Like example, like your ADAS system, ADAS. It is there in some car. Initially, the Tesla is having self-driven car, then Nissan, and nowadays Mahindra also have ADAS system. And the ML model generally we use. It can learn from the data and can remember it. Okay. And another one is the theory of mind, actually technically not yet achievable, and self-aware AI, self-aware AI, that is entirely theoretical. You will find it with in science fiction movie. I forget the name of the movie, that a person is went to some other planet and cope up with some aliens and all. I forget the name of the movie. A few days ago, it came into the play with Dhurandhar, but that flop. So those things, those are entirely theoretical. Now we consider the practical classification of artificial intelligence. Practically, we have rule-based AI. What is rule-based AI? It is nothing but it uses if-then rules. That is, if it's raining, you have to take umbrella. If it is hot, you have to put your AC on. These are rule-based AI. So for this AI, no learning required. Another one is machine learning. It learns from the data, and deep learning, it learns from the complex data using neural networks. So what are typical use? Who should use it? I given it in the table. You can take the screenshot and you can explore it. It is very simple thing. And I'm also not enumerating this slide in very large way. You can also take screenshot. So for pharmacy and healthcare system, when we use deep learning, we use one thing that is called NLP, that is natural language processing. So you can see some AI tools like Consciensus, Research Rabbit. So you have to prompt, you have to give some command in terms of prompt or in terms of natural language. That you can say compose all the information associated with quinazolinone nucleus. And if quinazolinone is associated with such and such activity, then you include this flavor, other flavor should exclude. In this way, you can write some prompt and it will search all the papers and it will give provide the information to you. Okay. And if you have some medical report like MRI, or you have some ECG, EEG, USG report. So this deep learning will read all these things for you and it will consult with some database using MLP. I'll share how we'll do it in future slides, and it will identify what is the probable cause of the disease and all. Okay. So in most real world problem, machine learning is sufficient, and deep learning is only required when you have some complex task or you have some complex data. Most practical AI applications that we are using are based on machine learning, not deep learning. This is the thing. So if we have some good idea about machine learning from pharmacy point of view, we can solve large number of tasks. Okay, and deep learning is very costly process because you have to train complex neural network, and for that you need GPU, high computational power, high cost increased incrementally. So deep learning is a costlier process. Yes. Now I use some term AI, AI agent, and agentic AI. It is a huge literature, but I make a table for you. You can take screenshots. And the main point, I'm just elaborating here, important things. The main thing is the simple artificial intelligence can analyze data, can generate intelligent output. But AI agent perceive the environment and it can take some action to achieve some goal. Okay. And agentic AI, it is an end-to-end solution. It can plan, it can decide, it can act, it can adopt automatically. Basically, agentic AI is a group of AI agents. Okay, so in artificial intelligence, its autonomy is very low, very low. Every time you have to give some input, it is user driven. And AI agent is moderate and it is goal driven. Until and unless you achieve your goal, it will do the work. Okay. And agentic AI is autonomous. Autonomy level is very high. It is self-directed. It know what it need to do. Just you initiate it, it will do your work. So for AI, involvement is time to time. After a very large time of interval, you have to update it. You have to give some command. Yeah, my voice may be break. Okay.
Yes,
And
it's okay now.
okay. But the Wi-Fi connection is fluctuating. I don't know why. It's happened. So another thing is in agentic AI, human involvement is very minimal supervision required. Okay, like your autonomous drug discovery pipeline. If you build your autonomous drug discovery pipeline, that if you only give that I need, you give the information of this protein or an uniprot ID of a protein. I'll show you later. We have some tool like that. Let's say something like that. In the end of the slide, I'll explain you, or I'll show you how it works. So, for a research point of view, you give just to provide the name of a protein, either its PDB ID or its uniprot ID. It will search the data, inhibitor data from the website by using web scraping. It will retrieve the data. It will prepare the data. It will build automatic model. It will build number of models and find which model is good. And according to the model, it will it validate it. The model it built, it validate it. Then it select the model. Then for the protein, it will study the receptor core, environment of the binding site, then in which cellular microenvironment, biological microenvironment the protein exists, what will be the probable pH and all, because it is communicating all these things with a server or database where all the informations are there. It is taking the information, curate it, take the decision, pass through some neural network, pre-trained neural network, and it will generate some molecule, and you check which molecule fit inside the pocket. It will dock, it will perform dynamics, it will perform binding energy. It check this molecule are synthesizable in my lab from my perspective. What is the pharmacokinetics and all? End of the day, you just start it, you go to your home. Next morning, you come, you see you have a bunch of files. You have the molecular information, validation data, tables for your publication, all the plots in 300 dpi for your publication. Every data is there. You just compile it, write it, or perform the experiment and go. This is agentic AI. Okay. So these are the use. Skipping it, you can take the screenshot and you can just go through it. You can understand. It's not some tricky thing. Now, what is the difference between generative AI, agentic AI, and AI? You can say a question comes in your mind. Why should I build agentic AI? I have ChatGPT, Gemini, or Copilot, or Llama, or Grok. Or I have lots of web server and tools, lots of AI tools are there. If I prompt, I'll get the data. I'll get my what I want. I can get it. You can get it. Definitely, you get. But the problem is those who are on the basis of generative AI. And generative AI generally use in background GPTs. That is generative pre-trained transformer. That means already what exists by which data it trained. On that basis, it will generate the info. Okay. So generative AI is like a parrot, stochastic parrot. Okay. Or this concept is also used in LLM, large language model, in probabilistic word selection or term selection or thing selection. So the parrot will go every house, every colleges, every institution, and it hear what people speak, what people are doing. It memorize it, and it also hear you. Then when you when you ask something to it, what it will do, what he heard from other institute, other organizations, other houses, from other mohallas, which switch according to you, it will mix it and provide it to you. This is generative AI. Okay, pre-trained transformer. Okay, it will generate some text, image. So use it with caution. It can say anything. Okay, and agentic AI perform tasks autonomously, can pursue goal, and you can say train your agentic AI according to your goal initially. What you want, what is your goal accordingly. So it doesn't have huge amount of information. It know what it for which it built. And AI agent is perform your some agentic capability and some generative task, and it will perform your work. You can also train your AI agents, so it will perform according to you. So here I'm giving you a pipeline of an AI agent workflow to speed up cancer drug discovery, because my work uh, generally focus on cancer, so I think it is suitable for you people. Thing is that, first of all, 1 minute, I have to open. Okay, as I told, so you can use any GPT file and you can use it. And you tell her such, and it must have this type of functional group and all these things, the feature you described. So it will go to some code repository, especially Codex or GitHub, and it use some Python libraries. What are there? I'll discuss later. And it will design some code simultaneously. It will go to the cancer database. It collect information using it. It will perform, build some ML model. It will perform all the tasks that I discussed, and it will also interact with generative AI and LLM models like ChatGPT, Gemini, and all. And end of the day, it will provide you some information. So now what I'm saying, it is sounds good, but practically in my lab, how I can do that? Okay. So before that, we have to learn neural network, and step by step, using baby step, we'll learn it, and after that, we'll build something. So in this way, the AI agent and agentic AI also help doctors and healthcare professionals using prompt or NLP. It gives information. It search the medical database, hospital database. It check the patient record, patient medical reports. It check the current research, and it builds some automatically builds some neural network or some programs, validate it, run it, and end of the day, it will give you some data. So you remember, your AI agent is a single work. Now you combine multiple AI agents, okay, and you will get agentic AI. That's it. Okay. When you use agentic AI, when you have to manage complex project, and when you use a streamline or a single task, single purpose task. I have only one purpose. That is, only you search the database, only you retrieve the data. At that time, use AI agents. So I do not construct this image. I took it from this this journal. So to do that in practical, so how in future we'll do it, how we learn, how to dig into it, we have to learn artificial neural network. Okay, it is a part of deep learning. Sometimes people used to say AI means neural network, artificial neural network. That is AI. It is a nice, maybe a topic of good debate. We'll do it after learning artificial neural network. So what it is? Very simple. Whenever you heard the term artificial neural network, you just something should click in your mind, that is IHO. What it is? Input layer, hidden layer, and output layer. So what is input layer? Input means input, we are giving something. What is output? What is the result we will get? And what is the hidden layer? So that is the trick that we are going to learn here. Okay. So what are the things? What is the chemical locha, technical locha is there in hidden layer that we will learn. Okay. Always remember, still AI, ML, deep learning, they know nothing. If you provide garbage data, you will get some garbage output. It is like garbage in, garbage out. AI हम लोगों ने ही बनाया. So if you have control on your input, and for AI, if you know what the things you are using in hidden layer, then you will get your desired output. Initially, where we are lacking and we are unable to set it, that's why we are not getting a very good result or optimum result or optimal output, optimal molecules. Okay. So neural network that came from neuron. So if we carefully look this image, this is nothing but our neuron. All of us, we studied it. So this is our dendrite. This is our soma or cell body, and this is our axon. Now, everything occur in this cell body. So dendrite, it receives some signal. So it is like our input. Then our cell body process something, and when it fire means it sends some signal. I'm going to use this term fire. Fire means in terms of neural network, the output is activated or not. The neuron fires. Neuron fire means it gives some signal. So in computational term, the engineers use this term fire. The neuron fires. Okay, the perceptron, actually it called perceptron. Neuron is called perceptron. So the perceptron fires. That is, it gives some output. Okay, so the axon will give some output and we will get our output. Okay, and this is our cell. So what actually happened in our cell body? That is very important. Okay, when we study the architecture of the neural network, we will study it nicely. What happened actually in this cell body? Basically, two things happen. One is summation, another one is activation function. And that is the key thing. If you have control on activation function, you will get very good neural network. Because if you use, suppose you are going to build a neural ML models or neural network model to predict the activity of some molecule. 50 to 60% time by using default option, there are lots of now GUI that they are to implement it. No need for coding and all. You will get good result. You will get very good validation result. But sometime, if you are encountered with some issue that your models are not developing, you are not getting very good R square value, how you solve it? You have to take the pain. What you will do? So then we have to explore or roam around this activation function, this weight sums around these weights. Okay. These are very important thing, weight. Okay. So we understand now when we compare a artificial neural network or man-made neural network with our actual neuron, the dendrites are my input. The cell body here is called node, and the axon is the output. Okay, in the node, some mathematical calculation is going on that we'll explore later after some time. And generally, for deep learning, the neural network we use is called DNN. Another thing is called transformer, that is advanced ANN architecture. We'll discuss it later. Now, another thing you can see, an input is connected with hidden layer nodes with a link. These links are called weights. Okay. What are these weights? And we are saying machine learning or artificial, 1 minute. AI or ML can learn from the data. How they learn? What actually happened in the learning? So to understand that, we have to understand this weight, and we have to understand weight. Actual learning is going on here. The weights are responsible. The links are responsible. These links, all these links are responsible for learning. How? We'll do it in our hand. So what you have learned, artificial neural network has three parts. One is input layer, another one is output layer, and the third one is hidden layer. Okay. In this case, there is 1, 2, 3 hidden layer. There may be a single hidden layer. There may be a 2 hidden layer. There may be a multiple hidden layer. Okay. Trillions of hidden layer may be possible. Okay. So now we understand how we want to understand. So remember, we are going to finish it with 15 slides. So this is slide number 1. Okay. 15 to 16 slide, I think. So now we understand, or we will explore how neural network work. काम कैसे करते हैं neural network. So actually what happened in our body, we have a neuron. This is our cell body. So our sensory organs can feel touch, can smell something, can sense heat. We can taste it is sweet, or it is tikha, it is hot, or it is karwa, whatever it is, bitter, and it gives a signal to our neuron. Accordingly, our neurons send a signal to us, take this action. For example, our sensory organ sense it is a hot day. Temperature is around 40 plus. So, how it signals to our neuron, it again send a signal, put on the switch of AC. Okay. Or it is cold, or there is a mosquito in your body. Your opposite hand will go in that direction, kill it, to smash it. Okay. In this way, our neuron works. Okay. So, to understand how artificial neural network works, let me consider a small data set. Okay. In this data set, this y is dependent variable, and the xi, that is x1, x1, x2, x3, these are independent variable. Means the value of y depends upon the value of x1, x2, and x3. Correct? Very simple thing. No rocket science. Okay. So we are using only this data set to learn how actually neural network works. Okay. So this is slide number 2. Here we have our data set, which consists x1, x2, x3. These are independent variable, and upon them the value of y depends. It is dependent variable. Okay. So now we consider the first case. That is item number 1. Okay. Serial data ID 1, 2. This is 3. This is 4. This is n. Okay, lots of data are there. Okay, so we consider this one. Remember, the value for x is 0.51. Again, I am repeating, very important. Remember, x1, the value is 0.51. For x2, the value is 0.97. And for x3, the value is 0.6. So just you can remember, x1 is 0.59 and 6. X2 is 9 and 0.9 and x3 is 6. 596 and output is 0.7. Okay, now 596 and 7. Remember. So here we give input. X1 is 0.5, x2 0.97, and x3 0.66. So we provide this input to our input. Okay, and after input, it will go to the hidden layer. This input go to the hidden layer, and we set some weight. What is the weight we'll discuss later. This is nothing but the priority. Okay, I'll explain it. No worries. So computer randomly assigns some weight of each input. Okay, so you can say in layman term, weights are priorities or importance. For example, you are going to buy a car. Okay, second-hand car. So what you will see, built year, model year, that is, it is a 2023 model or 25 model or 20 model. Then you will see it is a petrol car or a diesel car. Next, you will think insurance expired or you have some insurance. So among these 3 parameters, that is model year, then it is a petrol or diesel car or insurance year. Which parameter should be more prioritized? For me, it may be vary, but for me, it is the model year. If it is an 2018 car, it might be a BS4 car. Or if it is a 2024 model, that should be a BS6 model. So must be I will go for a 2024 model. Okay, so I give its priority. I give the priority to the model year. So in this way, it will set the weights. Okay, I'll explain it nicely in future slides. No worries. Then from one hidden layer, it will go to the second hidden layer. Okay, and this is called forward propagation. And the thing happened with x1 and x2 to node 1. So h1, that is hidden layer 1, hidden layer 1, h11, hidden layer h22, 1 2, it is 1 2, it is 1 3. Okay, what happened? All the input will go to the hidden layer h1. Same thing will come to hidden layer 2, h12, same h13. Okay, so these are the nodes. So this is called forward propagation. Okay, so everything came into h1 will pass h1. This is 1. It passed to h2, 1, h22, h23, h24. The information or things go all these 3 layers, and these things is called forward propagation. Okay, forward propagation. Remember the term. Okay, and from the forward propagation, we'll get our output. Right. So simple. We give some input. And we'll get our output. So what actually happened in this layer? How it learned? So what it will do? It will calculate a loss function. Remember, our data set. 0.5, point number 97, 0.66, output is 0.7. So in the first, at the very beginning, when the network starts, it ended up with a value you can see 0.28. 0.28. Instead of actual value 0.7. Okay, so it predict 0.28, but the actual value is 0.77. Now the difference is called cost function or loss function, okay, or a mean square error, MSE, okay, anything you can call it. Okay. Now what happened? It will perform a task called back propagation. You can say if you have command on back propagation, you will be the master of AI. It is the thing which makes things possible. And it started in 1986. Three great scientists published a paper on back propagation, which makes AI possible. You know, what happened in back propagation? Actually, it will go and adjust these weights, priorities, okay, or importance. We have some weights here, okay. We have some weights, weight 1, weight 2, weight 3. We have some weights. If you look the previous slide, we have some weights, okay. It has some random value, 1, 2, 3. Now, using back propagation, it will update the weight, okay. And again, there is a forward run, okay. And it updates the weight. Now the weights are updated. Again, there is a forward run, okay. And check, now the value improves. It is 0.45. So you can tell me, is it theoretical? No, we'll do something in our hand. I will show you. So same thing is going on. Same happened. We'll code it. No issue. Practically, you can see. So it will update the weight, and you see the value is 0.45. Again, it will calculate the loss function. Simply, it will subtract the prediction from the actual value. Okay, how much? What is the deviation? Or what is the loss? What is the how much error is there? Accordingly, it perform back propagation. Okay, it will go back, and from node by node, actually, it will go node by node, back propagation. Okay, and it will update the weights again and again and again. Okay, and now you see we'll get a value of 0.71, which is pretty close. Okay, so you remember 0.71. Okay, actual value is 77. So you cannot get exact real life value using AI. It is true. Okay, so we'll try to get very close to near actual value. Okay, and yes, sometimes if we do some other modification that I'm not going to discuss here, it is some complicated things. But yes, we'll get actual value. Actually, big research labs are doing that something, okay, to get very accurate value. In this way, a neural network works. So I finish it how neural network actually works in 13 slide. So in more briefly, can you people understand? Can you people able to understand how actually a neural network works? Yes or no? Anybody can respond. Hello?
Yes, sir.
Any doubt to anyone? If you want, I can repeat, or later you can ask me. So now we do it We performed it for item number 1. Again, we do it for item number 2. Again, we do it for item number 3. Again and again, we'll do it for n number. And again, we'll do it until we come to last. Okay. And after that, we will get an average weights for all the data, because for this there is a weight value. Obviously, for item number 2, there will be another weights. So after calculating all the weights, we will the neural network will calculate the weight for all the data set. Okay. And then it will give you the value. So when we calculate it for all the value, it called batch gradient descent. No need to go inside the math, because we nothing to modify inside batch gradient descent. Just it's a derivative equation. So by modifying this equation, you cannot improve your result. And this is called epoch. What is it? Performing or examining each and every data point is called epoch. So in programming, you can set the epoch score. Okay. So it will help you in future when you build a real neural network. You can set the epochs and you can check the epochs, how many times you will go to each data point. That certainly increase your accuracy. So this is called forward propagation. Look carefully. It will go the forward propagation, and every time it will calculate bias and weights and calculate the output until and unless the output is very close to the actual output. Okay. And it is called, this one is called back propagation. In back propagation, it is doing this math, back propagation math. We will explore this math. Okay. And you'll adjust the weight. We'll explore this math. So it will go and continuously update this biases and this weights until and unless it will find a weight value, okay, for which you will get a result very near to the true value. Actually, this is learning. How neural network learn? It continuously update or modify these weights, continuously update and modify these W weights. So for what value or for which value the output is very near to the input. Okay. And that is also called training. Training means we find a W value. For example, W is equal to 8. Okay. So when W is equal to 8, the model is trained. When you give new X1 or X2, instead of X1, if you give X5 and X6 value, this weight value is 8 or something, lots of words are there. It will give you proper output. This is learning. Okay. Continuous modification of the weights. Okay. And it is with the help of this, it occurs with the help of this back propagation. Now we discuss the architecture of an artificial neural net. Okay. So we know this is our dendrons, this is our input, and this is our weights. Okay. And this is our cell body. Okay. And this is the axon. Axon, output, this is our dendrons. Okay. Dendrons, this is our soma, our cell body. So for the cell body of an artificial neural network consists of two things. One is called bias, Another one is activation function. So bias is nothing but summing junction. It will do only perform addition function. It will sum. What it will sum we'll discuss later. And the activation function are some algorithms. What are algorithms? We'll discuss in machine learning part. Okay. So these two are responsible to fire a neuron or to provide some output or to activate in node. Activation of node. Okay. This is the basic architecture of an N. So now we study what is weights. Weight होता क्या है? मान लीजिए, so I got a job now working as an assistant professor or something. It's my childhood desire that I'll buy a home in a very good township. Now, before buying an apartment in a township, generally what we'll consider how much spacious my apartment is, my flat is, that is area. How many bedrooms are there? How far this township is from the city? Okay. And is it a new building or it is an old building? What is the age of the building? Okay. On that basis, I'll assign weight. Okay. So for people to people, the weight varies. Okay. So these are my weights. And this is on the biases, and for that we'll get some value. Okay. So actually weights where actual new learning is going on. Modification of these weights or continuous modification of the weights help us to find a particular number. And that is learning actually. Okay. Now, for me, how spacious the apartment is important. So I can rank it weight, I can assign a weight of 1 or priority 1. Then how old it is, that is my priority 2. Okay, because if the house is so old, then I will not consider. So in my priority, and if it is very new and it is small area or small flat size, that doesn't suit me. So I assign an weight 2. Then how much bedrooms are there? They're also important for me. I'll assign it 3. And how far it is for the city? I will buy a car if it is so far from the city. If the price is low, then I can. It is least prioritized for me. I can travel for my office half an hour more, no issue. So I'll set a priority. In this way, we set the priority. So sometime manually or we set some rule on that basis, you set the weight or you give the priority to the inputs, or sometimes the model itself prioritize the work. So these are weights. So in very simple term, weights are the number that represent importance. And these weights are adjusted during training. For me, molecular weight matter more in compared to log P. Because if I am going to design a drug whose molecular is 1000, I cannot reduce it. Because ligand binding is complementarity of size and shape. Shape and charge, sorry, so not size, shape and charge. So I can modify the charge, but by attaching some functional groups. By changing the groups, I can modify the electron density of the molecule. But if I cut the molecule, it will be problematic. No, I can't do that. And if I'm having very big molecule, I cannot use it. But it will fit. So for me, when I build some model and something using something, when I use some AI for performing some calculation associated with my drug research, I set molecular weight in first priority. Okay, then we can PA optimization, log P optimization. We can optimize the log P. Okay, for image, there are lots of parameters like brightness, then exposure, hue, gradients, number of things are there. But I think pixel matter most. So pixel should give some more priority. So if you know what type of data you are analyzing and what the which parameter you set for first priority, or which way should get the first important, best importance, or top importance, that either you can set it default or you can prioritize, and it chiefly depends upon practice, and skill. Then initially the model run, it will using some random weights. You can see when you run some ML or AI model, you'll find the random number. Or when you run docking, when you run Autodoc Vina, we are everybody familiar with it. So same ligand, same protein. You run the docking repeatedly, you will get different docking score. You will never get exact docking score. Okay, you have a protein, you have a ligand. Using Vina, you dock it. Again, you dock it. You dock it using another machine. You will never get constant docking score. It's vary because of random number. So it is recommended you perform the docking for at least for 10 times or 5 times. Then you report the average docking score. Okay, is another issue. So first, the model runs in forward direction with some random weights. After that, it will adjust the weight until and unless you will get a value very close or exact to the actual output. And that means learning. That's why in this way, the model learned or trained. And when it trained, it stored the value in the system. So when next time you run, it will use that value. Okay, short-term memory. So this is the things I tell you. It's called backpropagation and optimization. So in optimization, there is an algorithm work that is called gradient descent algorithm. Backpropagation and gradient descent. If you have a command on these two things, you will do very good. You can build very good AI model. So you see, when we see an AI model, these are weights. These are weights. If you calculate, you can take the screenshot and you can calculate. It has total 13 unit weights. Okay, 32 unit weights. Okay, it adjusts all the weights to get your value. That is learning. Okay. So this is all about weights. Now we discuss biases. What is bias? That is summing function. So suppose you have a data set, X and Y. When X is 0, Y value is 2. When X is 1, the value is 2.5. It is for example. When the value is 2, it is 3. So every time you can see there is an increment of 0.5. So if you plot it, you will get Y is equal to mx plus C. Everybody you know. So the C is the relationship between your X and Y. M is the slope. Okay. Mx plus C. So this C, okay, is the relationship between these two data. It will help it. And this C is called bias. Okay. And the M is your weights. Okay. It is well known. Whenever this is a well known equation, everybody uses it. Y is equal to mx plus C. This for artificial intelligence, this C is the constant for Y is equal to mx plus C, and for ANN, that is artificial neural network, the EC is nothing but your biases, and is M is your weight. Okay. Then if you plot it, you will get a bias of 2. Okay, and W is 0.5. So that means whenever you give some X data, you will get Y. Okay, so very based on this principle only, every N neural network work. Okay, the C is your bias. Now everybody are familiar with USR, Hans equation, constant 1 parameter 1 plus constant 2 parameter 2 plus and last C. Okay, so for this we can use a function called summation function. Okay, and in AI we have number of inputs x1, x2, x3. Basically we use this equation in background and we find weights, we adjust the weights. Initially we use a random m value, and after that we adjust the m value and we will find C. Okay, how? So you remember that data set initially I shown you. Okay, so it is a single node. It is a single node. It consists of one activation function F, and here is a summation function M, and these are my weights. Okay, and these are my inputs. So wow, don't worry. It is the short form of that composite equation. Looks like the Hans equation in QSR model. Constant 1 parameter 1 plus constant 2 parameter 2 plus n biological activity. So here value of x is equal to 1 up to n. If n is equal to 3, that is x1 w1 plus x2 w2 plus x3 w, and then biases p. Okay, so this is nothing but that equation. Okay, now for simplicity, now my input is here 1, it is 3, and it is 3. I set the priority w1 for randomly or manually I choose it by any means. At w2 is 1, and I set priority w3 is -2. It is less important for me. Okay, then using same formula, w1 x1 4, w2 x2 3, w3 x3 -6. Very simple. This input 1 into weight 1, nothing else. Okay, so input means here x, x1 into weight 1. Okay, so this weight I multiply it with the input value, so I get this values. Clear? Very simple, nothing, no rocket science. Then if the bias is summation function, so if I add all these value, we will get 1. Okay, and if we add all these value, that is 3 plus 3 plus 1 7, so my bias is 8. Okay, this simple calculation is going on inside the neural network bias in node. Clear? Now we calculate the bias, and now we perform an activation function. What is activation function? Okay, so activation function is a decision maker. Okay, there are large number of activation functions are there. You can go through some literature, or if you search in Google list of activation function used in mm, 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 uh, artificial neural network, you will get it. Okay, so I'm going to just explain. So first of all is, yeah, I will explain ReLU, because ReLU we are using very widely. So here is sigmoid activation function. In sigmoid activation function, if you look this plot, one moment, I have to delete it. In sigmoid activation function, you see the lowest value is minus. Here it is minus. And the maximum value is 1. If your bias is 0, only negative, then the value is 0. If it is 1, then the value is 1 here. If your value is 9, then also the value within 1. Okay? When no matter how positive it is, the value always 1. So if the activation function is 1, then the neuron fires, it will send a signal. If your value is negative, less than 0, 0 less than 0, then there is output is 0, there is no signal. The neuron doesn't fire, it will not send the signal. Likewise, ReLU works. Okay. So ReLU activation function, how it works? See, here it is written, it is something like that only. Here R is, so it is something like that. Okay. That means if the value of X is greater than 0, then output will be the X. If the bias, that is the input, is less than 0, then the output is 0. The axon will pass no signal. Okay. These are something called activation function. Is it some logic? Or it's something like gate, logic gate, NOR gate, AND gate, and NAND gate. So sometimes you can add one or more activation function to make your model good. And actually, this is the thing help us to develop good model. Actually, and where you have to use, where you use which type of activation function really matters. Okay, it's not because all the models are available in the literature, on the scientific community, or in GitHub. They use some activation function, but for your data set, that activation function may not work. So you have to change it according to you. That's the thing. Okay, so rectified linear unit, that is our ReLU. Generally, we and I, especially I, use ReLU. Why? Because vanishing gradient. Vanishing gradient means um, here in sigmoid function, there's something called vanishing gradient. That means you have a sigmoid curve. No matter if your value is 10 or 9, no matter if your value is 9, your output is within 1. So every time, next time, on that basis, it will update the weights. And now initially it update with 10, now it's 9. So now it come to 8. The value still less than 1. Gradually, the magnitude of the value is decreased. So actual information lost. So this is the mota concept of vanishing gradient. So in sigmoid activation function, in RNN, recurrent neural network, when you study protein, we'll discuss it later. So this is a very big issue. That's why we use LSTM, long short time term memory, LSTM models. So in regular pharmacophore model, activity prediction, good or bad molecule, active, inactive classification, the work generally would do in medicinal chemistry point of view, we use ReLU. Okay, this is rectified linear unit function. It is nothing but this equation. Okay, the range is 0 to infinity. What it means? X again greater than 0, then output, if the bias, this is the bias value is greater than or equal to 0, then your output will be X. No loss. Okay. If your bias, if your bias value is less than 0, then your output will be 0. Okay. Will be 0 because this is the 0, this is output O, this is 0. Okay, this is nothing but activation function. And if you use some good library, deploy ReLU, this type of things is good enough to deploy it. So nothing code is required. But in our real life practice, we'll build a simple ReLU, and we'll show you. I will show you how you can do it. So if your output is greater than 0, suppose 2.5. Here, if it is your output is 2.5. Your bias value or input, this input is come from biases. That is our cell, our neural network node contain two things. One is bias summation function. আরে নো यार, এই একটা সেশনে আছি, পরে কল করছি, দেখো. So if it is M summation function and another is activation function. If this bias value is 2.5, if this bias value is 2.5, then your output, okay, in this way it will work. ReLU. Then what is gradient descent? Okay, basically it is a partial derivative term, but I want to explain it in a very simplified manner. It is an algorithm which calculates a parameter called new weights on the basis of old weight, old value, and this function. This neta nabla loss of theta. This is nothing but your loss function, gradient of loss. So when you see nabla, that means partial derivative. So loss of theta means how much lost. That is y actual minus y predicted. Will tell you what is the difference between your predicted value and input value. From there, we calculate theta on the basis of change of that output. What is the change? When the change term came,
Hello. Hello. Sir, your voice is breaking.
of change. So it happen initially, we'll get a value, or adjusting the weights, we'll get a value of. Hello.
Your voice was breaking.
Yeah, it is
Now
okay.
It's okay. Yes, it's okay.
Hello, now is okay.
Yes, sir, it's okay.
Yeah. Sometimes it is depleted. So, and neta is the learning rate. in which rate it will learn. It is fast or slow. Basically, you can adjust this parameter. You can set this learning rate to develop your model. If you build a neural network and sometimes the model is not working, then first we check the weights. Either we set the manually. Once we set the manual weight, definitely it will not work. Then we change the learning rates. Okay. So yeah, you can take the screenshot. This is the things why activation function matters in AI. I make a table. I'm not going to discuss this things. You'll get bored. So try to use ReLU every time. Okay, and so, but sometimes when we do some binary classification of the drug, we use fingerprints like at Animata clusterings, or we took Morgan fingerprints or topological fingerprints. We have to use some sigmoid functions at that time. It is slow, computationally expensive. Really, it takes use time, but ReLU is fast, no loss, and in deep QSAR or in deep learning model, efficiently you can use it and it avoid vanishing gradient. You can retain lots of informations. Sometimes we use pharmacophoric informations or some other rational drug design informations to build a model, so that information retained. Okay, the magnitude of the parameters retained in ReLU. Now we use backpropagation, that is on the basis of that output, it automatically adjusts biases and weights. Okay, generally it adjusts the weight. When it adjusts the weight, automatically the bias value are changed because we multiply the input with it, then we multiply it, then we add it, then we add it, okay, in sum it. So automatically, if you change the weight, and the bias value will change. Okay, it compute loss function gradient, error gradient. What are they'll discuss later. So the backpropagation learning mechanism generally update the weight. Okay, so here I use error gradient. That means difference between prediction and true value. And gradient means every rate of change, in which rate it is changing. 0.5, 0.2 to 0.48 to 0.6. Gradually it's changing, and until and unless you get 0.7. Okay, so in which rate is changing, this gradient it calculates. Okay, and error gradient means sensitivity of error for each parameter. Very simple thing. Okay, so it will tell us two things. One is direction. In which direction? Shall I change this weight? Shall I change this weight? Shall I change this weight? Shall I change this? Or I do something here. In which direction? And how much should I change? That means initially my bias is 4. Next, I want to change it. Shall I go 5 or shall I come 3? All these things will come from, we can get from backpropagation. And it is, you can say, if you are very propagation, you will get full command on AI. So it is the very efficient technique, and nicely can weight the change, update the weights, and scalable. If you have trillions of millions of or thousands of your nodes weights, that propagation algorithm sufficiently handle it. Okay, and it can automate the learning process. So learning means changing the weight. Once you have some weight, for this weight, I'm getting good result, the model learned. That means some number. Now, here I use one term, gradient of loss. I use one term, chain rule. Okay. And previously I used gradient of error. What are they? Are they same? Yes, they're same. They mean same. In different article, different paper, different literature, you will find these terms, but basically they are same. Okay, this is nothing but it is a vectorized quantity because we have some scalar quantity. When you derivatize some scalar quantity, you will get the vector quantity. It is a S-level math, so we know it, and we will get this Nebula loss function. Okay, and for the depiction, I just show you what is the actual math, partial derivative going source under y, under these things. And this is a very glimpse of math. Uh, Now it is not our cup of tea. Okay, so chain rule. Chain rule generally used for composite function. Okay, so suppose we have a function that is the gradient of x. Then x is the function gx, and it is a function. It is another function. So one function is another function. To solve it, we have to use chain rule. So the simple thing is first you derivatize it, then you derivatize it, and then you multiply. That's it. So what is the derivative of this g? Okay, x. Okay. So first inner derivative and outer derivative. You perform simple derivative of inner value and outer value, then multiply. This is called chain rule. Very simple. So backpropagation is another advantage that. So for 1 to 4 units, so item number 1, I show you item number 2, item number 3. In the data set, I showed you. For that, each of the time we perform we perform some calculation. Okay, so up to 4 it can repeat. The epoch is repeat up to 4. So when you set the epoch in future to build your own model, if you initially set 1, next you can set 5, then you can set 9 in 4 interval. The backpropagation can handle it. So initially I told the name of 3 scientists. So these are the 3 scientists. They published a paper in the year of 1986. Okay, the landmark paper, and this paper helped, and that is the paper based on which modern AI developed. Okay, so you can download this paper and you can get the insight of backpropagation. Okay, so lots of theories I covered, and here I want to show how much time I covered. Oh my God! So there are various neural network model proposed by a number of scientists. The first model, okay, and so it is a weighted sum model which have only single node, and the basic things is the same thing. If the value of x is less than 0, it is 0. If the value and the activation function, if the value of x is greater than 0, then 1. So that means they use sigmoid function. Okay, so they use sigmoid function here. Okay, and when we have single layer neural network, single layer, only one layer. This one, only one layer. This is only one. Okay, it is called perceptron. Follow the rule logic gate, AND gate, OR gate, NOT gate, NAND gate. Nowadays using exclusive OR gate, bubble OR gate, all these logic gates they are using. We studied it in our B form, so I'm not going to describe it. When we have multiple layers, it is called MLP. So what is MLP? Actually, full form of MLP is multi-layer perceptron. Okay, MLP means multi-layer perceptron. So remember, the heart or main calculation in neural network is going on in the soma or in the nodes, that is summation function and activation function. Okay, so here I described that every day new type of neural networks are coming. There are a large number of various types of neural networks are there. And for pharma perspective, I prepare a table, comparable table. and selectively few things I'm going to explain, not everything. I can't cope up with this time because it is a huge thing. So you can take the screenshot and it is a cheat sheet for you. If you want to learn some network, you can get lots of YouTube good videos that verify it, who prepare weeks or Stack Overflow or in Code Geeks or GitHubs. In these websites, you'll get a detailed explanation. Or in Python website also, you get the explanations. You can study. So the most important network that we are using for de novo design of a drug is recurrent neural network, okay, and convolutional neural network. So in the first slide, remember we use the tool called DrugX. Basically, it uses RNN, set the RNN, and if your data set and the training file, because this file we are having some problem actually. All the model in drug discovery field we downloaded from GitHub and run it in our system. It required a training file or train file that is called prior file. And this prior file is not trained by us, not in India. Using some big computer cluster or workstation, the author trained it and they supplied it for publication. The train and sometimes they happen, they will not disclose the optimal prior files also. They will give some prior file which fit with the data. If someone or some reviewer want to check their work, it will fit with their data shown in the table. So they keep it with them, the training prior file. When you train the network, it will generate some data that is updated bias, updated weights. That information is written in that is called prior file. Okay. Or sometimes you can write it in JSON file also, PKL file also. Okay. So PKL file are readable. You can open the PKL file and you can explore it. And it is easy to generate, but prior files, it is difficult to analyze, but it's secure the data in its IN. So you'll find they use some PKL file or prior file. That means that training the dataset may not suit the dataset you are using, but the prior file, the training file you are using and the settings you are using, it's not appropriate for your dataset. And that's why you are ended up with some molecules not interesting. Okay. So it is better you train your own model and you optimize the network for your data. And convolutional neural network generally used in Genina, software called Genina. They perform CNN-based convolutional neural network-based docking. Okay, very good docking. Using Genina, you can perform Semina docking also. It is free. So installation is a bit tricky, but you can use it using Docker. So briefly, I am explaining what is neural network. So, okay. You just look at how to stop. I don't know. Okay. That means if you look around it, what it means, that means this is the node and activation function or biases or weights. It is repeating and repeating again. It is repeating. Okay. That means, so what it means actually? So in a very simple word, suppose we are having input x0, x1, x2, x3. For x1, when x1 is an input, it will calculate and weight information to get output. In traditional neural network, for x1 also, we will calculate another weight one weight 3, weight 4. Then we calculate we'll calculate another gradient that I explained in previously. But in recurrent network, this information is passed. This weight information to it. Then using it, X1 is predicted and again W2 is modified. Then this modified W1 is passed in third network. Here it is W2. Okay. Now X2, during the prediction of H2 from the input X2, initially they use this weight. Again, it is modified and this is repeating and repeating. Okay. So this is called recurrent neural network. That means the weight and bias information we pass to the next neuron. Okay. So it has a drawback that is called vanishing function. That means initially it used a random number called 10. This input, it is now 8. And this 8 is the network passed this information of 8 that I used 8, I get good result, you can use it. So this network, this neuron, use 8 initially, and after that it optimized as 2. So in this way, it will pass, and end of the day, we ended up with a. So there is a loss of information. Okay, for this we need 8. For this, we ended up with 0.04. Okay. So there is a loss of value or number or data. So that is actually vanishing gradient. So it is very useful for de novo design of drugs where this information is less required. But for sequential data, suppose you want to work with DNA, you want to work with some text, you want to work with some protein sequence where position matters. That means you have a DNA sequence like A, T, G, C. In this sequence, G, C, certainly important, as well as their position. After A, T should come. After T, G should come. After G, C should come. If you do some network, it forget the prior information and it will give an output like A, G, T, C. It switch the position. Okay. Then you end at it isn't. So at that case, you cannot use RNN for sequential data where this position matters or some speech. Something like I love Roshogolla. So the prediction is I Roshogolla love. Doesn't make any sense. So there you cannot use recurrent neural. You need LSTM. There are various types of neural network. Recurrent neural networks are there. I'm not going to explain in short. Briefly, I'm giving you the flavor. Next time, all of you people are very intelligent, can explore it. Okay, LSTM, long short-term long short-term memory. Another one is convolutional neural network. What happens when we have a molecule? For a molecule, we may have large number of fingerprint or parameter or descriptor. So one of my friend or collaborator, Dr. Mosand, he is also from Amravati. He discovered a very good tool for QSR that is called Pi descriptor, and it generates 21,000 big data set. So handling those big data set, find a pattern is the trick word. So convolutional network, what it does, from the total matrix of a molecule. That means from each molecule, you generate a matrix of parameter. This matrix, it may be a parameter, it may be a fingerprint or whatever it is. You can extract some important features. Okay. Suppose for this feature, you assign it. For this, you assign another number. So that means you extracting some feature, and that feature ultimately you are sending to a neural. And another thing we are using, that is called autoencoders in generative AI or AI de novo design. Autoencoders are widely used, and specific autoencoder is VAE, variational autoencoders. Okay. So what generally to Python library, one is areas. These are two Python library by which you can deploy autoencoders, and you need GPU. So what happened? It recognized the image. Okay. From the image, suppose you have a handwriting. You have a student. You tell them write 9. Some student write 9 in this way. Some write 9 in this way. Okay. All are 9. Okay. So how it predict this 9? Okay. So for in this purpose, they will people will use autoencoders. So that means first of all, the system takes this image, particular image, and encode it. Then it will some code, and after that it decode it and identify what is 8 or 9. Okay, these things actually work in airport. Every time now you use Digijatra. So in Digijatra, no matter after taking a good shower or after a hectic journey, the local train in a very crowded train, you get up and you take a picture and register Digijatra. And after that, you take a good shower, you wear very good dress, and you go to airport. When you stand in front of the scanner, it identify you. How? Background autoencoders are working. Okay. So very shortly, I'm explaining it. So another one is neural network. We use molecular graphs. This also used by Facebook and Insta, all social networking sites. They widely use graph neural network. In briefly, what happened, because you cannot use graph neural network alone, you have to use some recurrent neural network along with a graph neural network to get some output. What actually happened? For example, and you are an input, okay, and some event happened. So there are lots of input. That means lots of users are there. Among them, what is the effect of that event upon you? It will identify it in very briefly. Okay. For example, you have a molecule. Molecule means molecular structure. It just looks like a graph. Here you can use graph theory. In molecule, there is a particular atom or group of atom or functional groups or a side chain is there. So the particular role of the group or atom upon the activity, it can identify. And accordingly, it can optimize or design new molecule. That information it can use. Okay. Then self-organizing map, actually Boltzmann machine. Okay. So graph neural network is widely used as far as I know. How much paper I explored. Oh, this is the molecule helicin. I explained later. Okay. This thiazolidyl thiazole. Okay. Thiazole nucleus. This molecule is generally discovered with the help of this graph neural network. So you can, for self-learning, you can go to this GitHub page. You can take the screenshot, and they have a menu of AI tools using Graph, using GAN. The software is Molchen. Using it, you can design very good molecule, variational autoencoder based. What are the tools available? Then based on auto regeneration. Okay. Uh, then chemical reaction based. What are the model? Lot number of things, bunch of things are there. You can explore it, and you can see how they work. And if you have the very small information around of artificial neural network, you can open their code, you can modify their code, no coding required. Then we will learn how in practical. If you want, I can share the code with you to run, how to set up. I can tell you, and you can modify the code according to you and run your own and do research. No issue. Okay, already these codes are available in the net, so no need to do some coding from the net. You have to change some important parameters on it. So if you now you have the knowledge, what parameter do what things do what, which part of the program I need to change, what which part of the program represent what type of modification I need to do. So you'll find some good models like it will tell you you design some molecule. That molecule is synthesizable or not in your lab condition. Okay. Then what is the protein target binding, drug target binding, or ligand target bindings. Okay, all these things you can do it with the help of graph and VAE. These things are available. Now one point thing, very shortly I will tell, that is transformer. That is translator, Google Translator. So see, something is written in Spanish, it transform it to English. How actually it do that? It use transformer encoders. Okay, or sometimes in Gmail, I will type something, what is the next word, it can predict. Okay, or in Quillbolt, if you say Mr. Avinash Babu is doing this work in her work, remember, in her work, so and so, it automatically identify it should not be her. You change it to his. How we do that? A model, some higher level of reinforced neural network. So initially we use Mr. Avnish Babu. So Mr. always someone use Mr. for a name. So it should be his, not her. Okay, so the information of this encoding is fast. Okay. And if you thing in the year of 2017, Google published a paper in a conference, not a one impact journal. It is a very good conference. Attention, all you need. Okay. In 2017, Google published this model. This is the model of a transformer, a type of neural network, advanced type of neural network. The neural network we discussed is the advanced type of neural network. उन लोगों ने किया that in 2025 one paper published says the transformer to change the future of AI. So one paper change the future of AI. Okay, so all of you should do some work. Will change the future of pharma. Hope so. Someday definitely will do that. You can explore this paper. Lack of time and all, I am not entering in depth. So now the important part, how we can implement AI, NANN. Okay. So first for that, to carefully understand it, you have to give some attention. First, we take an input data table. So same data table we are going to use. Okay. That is, remember, I told you to remember 0.5, 0.9, 0.6, 0.71, and we stopped in 0.71. Okay. And what is the limitation? I will tell you later. Now, I can explain the data mathematically in this form. Oh, I must delete it. What is the mathematics behind this data? Y is nothing but the function of x1, x2, x2, very simple thing. So, very simply, I plan a very simple neural network. That is, I give single layer, that is a perceptron only. So, x1, x2, x3, I pass one hidden neuron and we'll get y. It's the step one. Here, this step one of the program. We write a code that is use import numpy as NP. So here for simplicity, I use only a single library. In practice, in real life scenario, we use scikit-learn, Keras, TensorFlow, or to deploy or to implement artificial neural network. But for the beginners, to understand how how it works, I use only NumPy. That is good enough to learn for beginners. Okay. I think you will know about it. You know how to it, but it is. I'm sorry. I designed it for beginners only. Actually, me if you know, please. Sorry. So what I can say, if people just in Python day by day, because the Python is there in our next PCI syllabus. So it is important if we learn these 5 libraries: Matplotlib, NumPy, Pandas, Seaborn, and scikit-learn. It is the hub of 80%, 85% task you can perform with this library. Now, if you can ask, what is library? Look, think Python is a simply Royal Enfield Himalayan bike. Okay, it is a simple Python programming. Okay, with that bike, you can do city commuting, you can go to the market, you can roam with your friend and family. That's it. Now you want to go Ladakh. You can configure your bike with some Ladakh carrier. Okay, so Ladakh carrier is a library for Python. Now you want to go to Sikkim. Okay, and you have a pillion. Then you have to configure your bike by putting another backrest and back trailer or back carrier. You do not treat Ladakh carrier, okay, in that road because it's a congested road. If you put Ladakh carrier, size of the bike will be larger. You cannot ride in a congested way. So in this way, you can configure your bike as per thousands of hundreds of thousands of libraries are there by which you can perform a large number of tasks in Python. So if you add all the libraries in Python, if you load all the libraries, when you open Python, your system crashed. You may hang, and you have to install GBs you need GBs of hard drive. So heavy. So for the tasks, what are the library I need? I just use those library. I configure the Python within this library. So I think I can explain what is the concept of library, what library does. So NumPy library is associated with numerical calculation or numerical tasks, algebra, calculus, all type of tasks you can do with NumPy. Another maths or scientific tasks, engineering maths you can do is SciPy. So I keep it aside, SciPy. Matplotlib and Seaborn are chiefly for plotting. So whenever you do some practical, practical, we used to plot some. We have to build some plots. Whenever do some spectroscopic experiments, we have to plot some. We have to plot some data. So if in everyday life, everybody for QCI and NB and all these things have laptop, you install it, you install Matplotlib, and if you go to their manual, 1 minute. স্যার দেখেছো তো আমি জানি কিউসি এর জন্য। So I'm sorry for the interruption. So you go to their manual, you find how to plot it, and very simple things, or you can check my GitHub. Small programs are there. Very simple programs for C by 5 is equal to minus 32 by 9. How you do that? So very 1 or 2 line code you can write, and you do the practice. Okay. So and pandas, it is like Excel. Any type of data handling we can actually do with pandas. So here I import the necessary library, in this case NumPy. Then I load the input data. Okay, x1, x2, x3. So in an array form, okay, in an array form, I input all the data. Okay, and also by using NumPy array, I provided the output data. Okay, now I place weights and biases. Okay, so initially I use random.rand. This means use a random number. Okay, and here 3 to indicate 3 input pairs, and bias, there is one bias per hidden neuron. So you can change the number of biases in your actual program by changing it. You can update or develop your program. And here I set the random number for biases. And now I print for experiment purpose, or how the bias changes, I print it. Then I prepare 2 of 1, weight, second weight. And same thing I did for second bias, because we have 2 weights, W1 and W2. So it will be here and here. Okay, so W2 set here. Then I define the ReLU. Okay, so using a def function, I prepare a function. This function is ReLU. Okay, so here I use this ReLU function, and input is Z. That means if the value is more than 1, it will go Z. The maximum of 0 and 1, obviously Z will be high. If Z will be high, that will be the output. And I designed the forward propagation, use this function, and I pass it through the ReLU function. That means if my Z is greater than 1, there will be a value. If not, if 0, A1 is equal to 0. Okay, and then I will perform a linear combination of output. Basically, I did this math. Yeah. Then I calculate the loss function here. Okay. So in this way, using I solve this math, very simple. That is, what is the actual value? What is the predicted value? On that basis, I calculated MSE, mean square error. Okay, and I calculate the loss function, and then I simply code it for back propagation. Okay, and what is the gradient for W1 and W2, and through ReLU I pass to. Okay, and the value is this I set. Okay, but this ReLU Z. That means if the value greater than 0, fire the system. If not, off it. Okay. It is update the gradient that loss function here will be theta, it will be neta or alpha, whatever it is. So, and the neta value, I told you, learning rate, I can set. Okay. And after setting this, I updated the biases. You see now that you have a new bias value. And end of the day, I prepare a loop. Okay, this loop will do it until and unless we will get our n number very close to our actual value. Output is print our prediction for understanding purpose. I print several things. Yes. Okay, that will reflect in next slide. So when you run it in computer, you will find these values. Okay. Here we'll get 7 to 9, and actual value is 77. Okay. And if I change some parameter learning rate, okay, and initial loss, if I set manually the biases, then I ended up with 6.1. Okay. So what this output, if you have better bias initialization, the result will be very close. Okay. And if the loss is initially you have very low loss, okay, then we are very near to our actual value. If you have some higher gradient, healthier gradient descent path, the very shallow, then we are really very close to actual value. So terms and practice, I'm making it fast because it is almost 4:40 when I tell you about ML. So you can get this code from me and you can run it in your system. You'll get same type of value. Okay. So now, as I tell you, AI is the heart. ANN is the heart of AI or not? Data-driven AI, only data-driven AI at the heart of artificial intelligence, but not all AI. Like your rule-based AI, which use if and then rule. That is not at all your heart of an artificial neural network. Only data-driven and part of AI. Okay. So this is the comparison chart of why and why not. You can take a screenshot, no issue. Now we can take a break and I'm giving you a short task using very simple rule. You solve this equation. I'll return back within 5 minutes or you people can take 5 minute break. Okay. Hello.
Yes, sir.
Okay. See you within 5 minutes. Take a break. Yeah. Uh, shall we start again?
Yes, sir, we can continue.
Okay. So I think everybody successfully solved this issue. So again, just I'm explaining what it is. So if we look carefully, it is a function of a function. So this is the outer function, the inner function. So to solve it, we have to use chain rule. Okay, the outer function is power 10 and the inner function is x cube minus x square. So our chain rule says that is multiplication of outer function, derivative of the outer function and inner function. So we can say this is u to the power 10, and so we can write fx is equal to u to the power 10, and our outer function, if this is u, this is my outer function, and the inner function is u, is nothing but this. Okay, then on that basis we can write this equation. Okay, and after that we derivatives this u, very simple derivative, and we differentiate derivatize the inner function. This is the answer, and there's simply multiplication. Okay, and this is the final answer. Here we use a very simple rule. It is a power rule of derivation. So one thing, okay, I'll discuss later. Now we start machine learning. So it is nothing but a subset of artificial intelligence where the machine learns from data using without explicit programming. Now I use the term data. To learn machine learning, to execute machine learning, first of all, you have to understand the data. Okay, there are various types of data. Generally, pharmacy wale use structured data, and widely used. In specialized case, we use unstructured data or sequential data or time series data. So in structured data, two types. One is level data, where you see every images are leveled. Okay, and unleveled data. Here there is no level; they are not leveled. But here, so what is sequential data? Like your protein sequence graph is molecular structure. Then time series data is your pharmacokinetics data. Okay. Then your ECG data, USG data, image data. Sorry, not USG. Image is your USG data or X-ray data or your MRI data. Okay. Then your data like MD movies, molecular dynamics movies, drug-target interaction. These are multimodal data. Okay. So what is level data means? Suppose this patient, we have a patient, this is the ID, and these are the various parameters. These are various parameters, clinical parameter or some other parameters, any parameter there. And that if this parameter is diagnosed as malignant, so it is the level. If this patient having such parameter, okay, diagnosed as malignant, so this is level data. We level each and every the outcome. So y variable, dependent variable, y variable depends upon this parameter. But this is unleveled data. Here there is no y value. For example, we have a customer, age, the education, year of employment, income, credit card, debit card information, address. Okay, then but what? Why? What will do with it? Is it a good? Is customer one is a healthy financial customer one possesses a good financial characteristic or not. Is rich or poor? What? I don't know. So this is called unlabeled. Now machine learning, we know it. We have supervised learning, unsupervised learning, and reinforcement. So in supervised learning, we use labeled data. If we have unlabeled data, we perform unsupervised learning. In supervised learning, we perform classification and regression. Okay. In unsupervised learning, we perform clustering, dimensionality reduction. And generally, reinforcement learning is used in robotics. It is not at all our cup of tea. I never find useful in pharma sector. ₹1 coin, ₹5 coin, ₹10 coin. For each coin has some value. That is, it is one. Its value is one. Its value means you tender 5. Its value means 10. To tender 10. And each and every coin has some weight. That means suppose it is 5 gram, some weight, and it is suppose 30 gram. So all these things, these are the parameter, and this parameter and the value is the x variable, y variable, and we label it ₹1 coin, we label it ₹5 coin, ML model, and we'll get the output. When we introduce a new coin, is it a ₹1 coin or a ₹5 coin or ₹10 coin or ₹20 coin? It will identify. This is the very basic explanation of supervised learning. In unsupervised learning, we have number of players. And nowadays, I don't see IPA. I don't know individual players. So in the year of 2000, I used to see it, now not now. So using unsupervised learning, you can classify this pair who are batsmen, bowler, and who are wicketkeeper. You can classify them. Okay. Suppose if you have a bag, the bag contains some apple, some watermelon, but you don't know. You are not telling the computer if these are the information. If it is red, it is apple. You are not telling it. It has something, two different thing, or more than two different things. The model will automatically classify apple and watermelon. This is unsupervised learning. For example, you have some set of molecules. Okay, you have mixture of molecules. So unsupervised learning based on certain criteria, either by the help of what type of functional group they're acid or amine or amide, imidazole or indole or pyridine or what. On the basis of ring system, they will simply classify it. Okay, this is classic unsupervised learning. And this is a very brief example. And in reinforcement learning, we use level data. We are telling the computer if these pictures are for dog, these pictures are for cat. Okay, and you get the output. So when we give unknown picture or query picture using model, it will categorize it. Either it is a cat or dog, and it will ask for a feedback. Am I doing right? If the input is yes, you are doing okay, it's okay. If not, it will again update them. This is called reinforcement learning. It will modify itself. Okay. So prior to machine learning, we have idea of all those things. All of we have, but we have it. But again, I am just for recall. We need certain knowledge of mathematics, computer science, and descriptive and inferential statistics. Not all mathematics like linear algebra, calculus, and discrete mathematics. It's just what you need not to be expert on math. So what are the parameter? What it does? Okay. So if I change what parameter of this equation, what will happen? When I use it? Sufficient. The most important thing is, I'm not going to explain everything, but just telling you, The heart, or you can say the core or the expertise of machine learning is lying in two things. One is data, another one is algorithm. That is, for your data, what type of algorithm fits, that is important. And remember, it is not the algorithm, it is the data which fills machine learning. It is not the algorithm, it is the data which fills a machine learning model. Okay, so understanding of data and handling of data is very important in machine learning. Okay, so what is algorithm? It is nothing but a set of rules and it must have reliability, it should be speed, it has cross-platform compatibilities. Okay, so we're not going to develop some algorithm, but these are the basic properties. Now, what are the algorithms generally we use for supervised learning in level data? So there are lots of algorithms are there, large number of algorithms exist. Among them, we widely use. So you can use it. And linear regression and random forest regression, you can use it. It is very robust, accurate, and for large number of pharma and healthcare related data, it is good. Okay. Then we use XGBoost. Okay, so XGBoost is it can optimize. So what parameter I need to adjust, how to optimize, how I can perform hyper optimization. Simply you XGBoost or light GBM model. It has the capability to optimize the parameters according to your data, but the problem is you need very high-end compute. Okay. Then another is linear regression. Okay, and less. So these two are the another two algorithms we widely used in pharma. And for classification algorithm, we generally use 9KNN clustering, decision tree. Generally, we use decision tree for phylogenetic tree to study the mutations. Okay, we have shown a very small number of data. We use decision tree classifier. Else we use KNN cluster. And sometimes we use gradient boosting, XGBoost. It is also XGBoost is very good for classifying a large number of chemical database on the basis of actives and inactives. So you have trillions of data, millions of data, you just classify the active and inactive set. Okay, so you train the model and you simply classify the active compounds. Then you take the active compound and further calculation or experiment. So it will make life easy. So at that case, you can use XGBoost. And for unsupervised learning, for example, you have some MRI data, you want to analyze it, is it normal or tumor? Or you have some unleveled data, you want to classify them in various categories. So in unsupervised learning, K-means clustering. So it is a lazy one. K-means clustering, it takes lots of time, but you can use it. And you can use hierarchical clustering. It suits good for us. And if you want to perform dimensional reduction, most of the time we largely use a PCA. You can also TSNE, but it is a bit complicated, or a UPMA. Those are also complicated, but if you are working with Markov state model study, you have large molecular dynamics, 20 microsecond molecular dynamics data you have, then you can use UPMA. Else PCA is good enough for us. And quick algo selection rules I'm giving you. Look, it is not there in any book. On the basis of my personal experience, I narrow down it. So if you have, and that means generally we use some DNA, RNA data, or some smileys. Number of times we are using smileys. In smileys, USC, C, S, N, like this. If something is changed, C, C, N, S, the meaning change. So at that case, you use LSTM algorithm. You can use CNN. Suppose you have an NMR spectrum. So you want to build a tool that if you give the NMR data in PDF file format, it will interpret it. Okay, then you can use CNN. You have large tabular data. That means you want to build some QSR model or this type of activity prediction model or toxicity model or ADME ADMET model, you can use XGBoost. Or if you have some information of around hundreds or thousands or 200 molecule or 5,000 molecule, you want to predict activity or some parameter, you can use random forest. And if you have some small nonlinear data, like your pharmacokinetic data, or uh, is it increased or decreased, this type of nonlinear data, then you can use KNN clustering. Or if you want to check some linear trends, in case of pharmaceutics, it is widely used, you can use rigid or linear regression model. You can also use it for activity prediction. Now, one thing is that activity also important. So these are the metrics we generally consider. Most of us are well familiar with it. You can take the screenshot. What is the typical range? What is the acceptable range? If their value is high, if their value is low, what it means? I make a table. I think you just go through it and you can interpret what it says. And what are the generally we check for classification metrics? Generally, we consider in regular practice recall value. It should be high. It should be like this, the curve, F1 score. It should be balanced. And ROC, AUC curve, if you have an ROC curve. If you have this type of curve, you are lucky. And if you have this type of curve, far from the middle line and tangent line, indicate true positive rate is good. Okay. And decision metrics, every time this was actual number and this is the actual figure. So means I provide input of and my model can predict 466 as an active. Okay. So in this case, you see, I provide 439 as an active, but it recognizes 482. That means it has false positive. So in this way, you interpret this model. This is called decision tree, confusion. So not decision. Okay, I'm making it very fast due to the time constraint. It's nothing. So sometimes we are having overfitting issue. You will getting very 0.99, 0.8, 0.9. You can say, wow, my model is very good, but don't be happy. Your model may be overfitted. So these are the things in my ML model is overfitted or it is balanced model. And here I give a quick rule of thumb by checking the these parameters. You can check your model how well your model is. As I told, this how much far from this line your ROC curve is good. Value of recalls, both for recall and precision or accuracy, you have a very good combination of recall plot. Okay, so recall like this and AOC plot like this. A very quick understanding. Okay, now actually how you implement an ML. First of all, in ML, model validation, selection of good model interpretation play the critical role. Okay, and data retrieval, how you retrieve the data. But for this tutorial, I'm not going to show how we perform web scraping automatically, how we can retrieve the data. It is a time-consuming process, and I'll provide you data set. And another thing I am not going to show, that is molecular feature generation automatically. I will supply you a data set only. Then molecular feature generation, we generally use a Python library called RDKit. Okay. And the step is for that you get the data. Most important part is data cleaning and data standardization. Okay. Then we classify the activity. Then we calculate the molecular feature. We split the data in test set and training set. Then we train the ML model. That is, we values MX and biases. We adjust this value behind the ML. Same thing is going on. OS and bias. We just adjust and update this value. That is a training. Then we perform the rest of the work. And discussed with them, the organizers, that I'll show how you can perform AI generate molecule screening. But I think the time is time is running out, so I skip it. We can discuss it in some future session or some future days, coming days. So first of all, data cleaning. Okay, what it means? It means then we analyze data, we standardize the data. For example, you have some data 0.1, 0.2, 0, 0, 0.01, and you have an activity value 9. Now you see the magnitudes. Very small. When you plot them, you cannot find them. You get only a peak for n, 9. Okay, so very difficult. So very simply, using min max command, we can standardize and normalize the data. That is very important in machine. So that there is an 60% chance you will end up with a failed model. Okay. And for today's example, suppose we have a data set, it contains some smileys, and these are the descriptors. Okay. I have a program called, I have my own script by using RDKit. We calculate these descriptors. And this is the activity PIC50 value. All we know about it, minus log of biological activity is a PIC50. And it is a very good question, maybe for the future. Why use IC50, not IC50 value? Okay, and we also level the data, what is active, which molecule is inactive. In this, the basis of activity, basically we set a threshold. If the activity level is above 6, it is active. PIC50 above 6, it is active. If less, if lower than 6, then it is classified as inactive. Then same, we import required libraries. We use pandas, we use NumPy, we use matplotlib, we use scikit-learn standardizer. Then we use random forest regressor algorithm. Okay, and for validation, we use R-score, mean square score, all this. And generally, I implement ML using Jupyter Notebook, but you can also use using it is called Microsoft VS Code. So the benefit of using VS Code is that it is connected to GIT Hub, and it uses Copilot in it. So if you give some good prompt, it can get the authentic code from GitHub and it can patch it for you. Okay. So use a code to load the training data. Then we perform data cleaning. Then we separate features that from the training data, we identify PIC50. Then on the basis of we consider, we drop this ID, smile, activity class, and PIC50 to build the model, because Y data is my IC50. And your X data are the parameter. Exclude this. This is the meaning of this code. Okay. Data dot drop. कौन सा कॉलम ड्रॉप करेगा? आईडी कॉलम, स्माइलीज कॉलम, एक्टिविटी PIC50 column, because PIC50 is my Y variable and rest of this. So if we see the data set, only these are my X variable. This is Y. Okay. This is not at all required to build the model, and this is not required to build the model. Okay. And then we split the model. Now you can tune you can take any machine learning model from GitHub. You open the code, you will find this slide. Every model you will find this slide. X train, X text, Y train, Y test. Okay, training sets. So the test side is 0.2 and random state 42. Okay. It means 20% data is for test set, 80% data I'm going to use for trading. You can use 70-30, 70-30. So for 70-30, you put it 0.3. You can use 25%, 0.25. Okay. So you can randomly add until and unless you get a very good model. And you can also, but repeated time, I'll tell, I told it, random number, random state. You can change it. Okay. And there is no rule. It's basic on practice, and after doing lots of the things, you'll get an idea what the data set, what is the right. And you can build the pipeline. Basically, what we are doing, we know. First, we standardize it, then we normalize the descriptor. Okay. Why? Because few of my descriptors, suppose molecular weight is 500. Okay. And my activity is suppose 8. There is huge to start the learning process. To make it streamlined, we use some simple math. I'm not going to discuss here. So we perform data normalization. Here you can adjust the estimator value, random seed, depth value for better data handling. Then we perform model training. So it is very easy. Pipeline.fit is only one command. Train. X train, Y train. So model.fit. This is only one command will train the model. Very simple. Okay. So training, write a code for training a model is not a big deal in machine learning. So you have to take some pain when we scrap the data, when we get the data from the source, or when you standardize it, normalize it, clean it. Okay. Because splitting of data is only one line. Okay. No matter how big ML model you are composing. Okay. Then we evaluate the model. Okay. We calculate the performance protects R2 score. What is R square score? Okay. What is the mean square error? Okay. And we split this score. Okay. And here we perform something. I stored that it will store that information in text file for my future perspective. That when I compose the paper, I just simply copy it and make it. Then I perform the actual versus predicted plot. What is my actual activity and what is my predicted activity? I made a plot using your PLT. PLT means import matplotlib as PLT. So we are not going to call matplotlib every time. We are just calling it PLT, and we are making 300 DPI picture. And then we make a residual plot using matplotlib. Very simple code. And this command is used for say figure for 300 DPI. So label this, and we want to prepare a scatter plot, Y predicted and residual. Okay, that's it. This simple thing will make the plot. And after that, we perform a cross validation, mean R square CV, and we save all the validation result in an Excel file. Then we load the SB file, for unknown ligand, I'm going to predict the activity. And for that, I have to provide their ligand structure, name or ID, and their descriptors. That is, I have to provide X value, smileys, and ID. Okay. If I provide this information in CSV profile, automatically it will calculate predict the activity of this molecule, and it will save the result in an Excel file format. And once you run, you will get this result. Because for you people, all the data set I will share. I will mail someone the script and the data set. Simply you can run it. You can run it for your ligand and you can publish it. This is the code. Okay, you can use this model for your project, student project, or if you have very good data set, simply you just change the name. Query ligand, you can make an Excel file named query ligand, and where you save the script in the same folder, you save the script, you save the file, and initially you have to prepare your data set and rename the file in this capital D data set, and you run the script. It will no matter you have thousands of molecule, 100,000s of molecule, and what. So it will generate the actual versus predicted plot. Then this is the script name. How you run it? Simply open the terminal in Windows or CMD, that is the prompt in Windows or in Linux terminal, and type Python. Okay, then FDP underscore so and so, and hit enter. Okay, it will automatically run, and it will save the model performance report, residual plot, then test set prediction result. Okay, and query ligand prediction result. Okay, so ये आपको बताएगा टेस्ट सेट के लिए कितना प्रेडिक्शन हुआ, ये query ligand का एक्टिविटी क्या है, residual plot, and all the matrices R square वगैरह वगैरह जो हमने निकाला, and I think this information is sufficient for simple application, and you can also modify this code to get more parameters, and end of the day you will get this type of data. For 200 ligands only I performed it, and after test and training, after remove duplicate, I ended up with this ligands only. And this is the query ligand, these are the predicted activity, and this is the residual plot. So you can take this ML code and you just run by yourself, practice it. Once you are familiar with it, you can modify this code as per your own, and you do the research. Who cares? And I run it for a paper. It's under communication for 5,500 molecules. So this is the performance, and this is the ROC. Okay, so it tells this model I wrote is okay. You can trust it, no issue. Our lab is designing some tool by using this tool. It is a Windows-based app. You can convert any smile in SDF file, and it is a virtual screening tool. In background, it will use Veena. So the specialty is you create a directory, you put all your ligand in smileys format, SDF format, Mol2 format, PDB format, doesn't matter. Automatically it will prepare the ligand, and you give your PDB file, your receptor file in PDB file format, CIF format, Mol2 format, anything. It will prepare the receptor. You set an output directory where result will be submitted, and a simple configuration file like Veena, and you start it. And I found actually why I built, actually I found that only one tool is available in the internet or in the community. There is Pyrex to run virtual screening in Windows system. And other than if you do not have Schrodinger license or some other Windows-based commercial tool, so you can one can use it, but yet not it is publicly applicable for some thing is there, because I want to put some log. I am not a coding expert. So how you can put some log that no one can do something to this and that with that. And one of my students in MFARM project developed this whole tool called Anuprava, because everybody is familiar with Gromax MD simulation. The problem is Gromax is not an end-to-end script. You cannot perform ligand parameterization with Gromax. You have to use some third-party tool to ligand parameterization. But Ember is an very faster than Gromax, even compared to Despond. And it is you can parameterize it, and you can perform n number of MD simulation experiments using Ember. The problem is you have to write lots of codes, and it is tricky. But using Anuprava, you give the protein and ligand and tell how much time you want to run the simulation. It will run the simulation for you. It will make the plots. It will perform MMPBSA or GBSA calculations and everything. And then the next morning, you will have all the data. It is his MFARM project. It's going on. So we are having only version 1.1. And and the ML tool. So we designed one ML tool and we give the name EasyML. So the thing is that you can use this script. One can use it. It can automatically download. Only you have to provide protein name. If you give the protein name or UniProt ID, it will automatically search the internet, all the databases. As per OECD guideline, it will gather the data. It will classify the molecule in inactive and active. Okay. So it will calculate the fingerprint. It will run number of models using various algorithms, various fingerprints, and identify which algorithm and which type of fingerprint, organ or your topological or combined or RD kit or physicochemical descriptor, what type of parameter nicely fit with your database, and what type of ML algorithm is good for your data set. It will identify. On that basis, it will automatically screen a query database. Okay. So yeah, you have to give two input. One is you have to give query database, or you can link up with some AI tool which will automatically generate the molecule and it can predict the activity. Okay, and end of the day you will find a log test text file. So actually you can see what's going on in background. You can see, but most of the tool that available commercially or open source, when you run the command, everything is blank. After some time, some message pop up. You don't know what's going on in background. So in this tool, you can track what actually going on, where the issue arises, what is the issue I need to address. Okay, and how much time remains. If sometime your system off, the next morning or when you start, it will start from where you stop as well. Once you train the model, for the next time, for the same data set, for the same type of activity, suppose you are working with EGFR, you train the model, and next day you did not train the model against EGFR. It is already trained. It will ask you which model you want to use of EGFR to screen your ligand. That is, it will run on screening mode only. Okay, and end of the day you will get the data. All the data, these data are, I think, sufficient for publication. And step by step, it will ask you, are you want to use pre-trained models? If you say yes, it will check you all the models. As I told you, we are a poor man, we are not rich. So we save the data in PKL file format, not prior file. And using that file, you will just give the input, model number 1, 2, 3, or what. You have to give input and press enter. It will run. Now, this is a short video. I don't know how I can. Why it is not? Why the video is not? told me some problem may arise. I don't know why the problem. Okay, so it is a video of that model how it's work, and I'll run the video in separate slide. I don't know why it is hanged. Okay, so basically it will give you full log, all the data required for publication for each model. What is the ROC, and for a specific model, what are the recall plot, and what are the features are important for activity. What are the parameters are crucial for activity? That information also it will provide SAP analysis, nothing else. And these are the few publication of mine. Ray should go down. And thank you. For your curiosity, I just open the video. I think share.
Hello, sir.
Yeah, how to share entire screen?
Right now, just close the.
Okay. So nothing to share. Thank you. Thank you from my end. If anybody has any doubt, can discuss with me. Sir, thank you from my end. I concluded it. Hello.
Okay, sir.
Okay.
Thank you so much, sir, for such an enlightening and thought-provoking session. You truly AI machine learning in a right manner. Practical applications of AI tools for non-programmers, real-world use cases in drug discovery and pharmaceutical research, how AI can bridge the gap between theoretical knowledge and implementation. As rightly said, the future belongs to those who learn, unlearn, and relearn. This session has certainly inspired us to embrace AI not as a challenge but as an opportunity. Once again, thank you very much, sir. We are now opening the gathering for questions. If anyone has a question, please feel free to ask.
I think there is no question. It means two things. Either मैंने कुछ समझा ही नहीं पाया, और सब लोगों ने सब समझा समझ गया, कुछ बोलना नहीं है. जोकिंग एफर्ट. आप पूछ सकते हो, नो इशू.
Hello.
Yeah.
Sir, what resources can help me to learn more about machine learning without coding? Is there any resources we can access?
you can go to GitHub repository and you will find a page called data scientist. Basically, in when we start learning, because it is not there in our syllabus, and I never heard of Python programming, AI, ML in my student or PhD. So when I came to know about it, I used his pages, his tutorials in GitHub, data scientist, uh, and that literature will help you definitely.
Okay, sir.
Sir, any other question?
Yeah. Yes, ma'am.
Any other question from audience? Okay, thank you very much, all of you. Before we conclude, I would like to express our sincere gratitude to Dr. Debanjan Sen sir for generously sharing his expertise and time.
Thank,
And sir, I request you to accept the letter of gratitude from our institute and to our honorable management, organizing committee, coordinators, and technical team for their seamless support, and to all the participants for your active presence and enthusiasm throughout the session. Thank you very much, all of you, for making this session meaningful. We hope today's discussion adds value to your academic and research pursuits. With this, I declare that today's session is over. Have a wonderful day ahead.
thank you, ma'am. Thank you very much. Bye. Bye to all. Thank you for your patience.
Thank you, sir.
Hello. The present participants are requested to turn on their videos. Okay, thank you.